All right, benchmark A 5.1, simplifying algebraic ratios. All right, simplifying this right here, you'll notice it's two terms here, so we just can't cancel n's or 3's out. Okay, we got to factor everything like we did earlier, and then factor out common multiples. So let's take a look and see how this is going to look. So we got n squared plus 3n, and that's over 3n plus 9. Again, don't try to cancel that out. We got to factor here. We got a greatest common factor of n right here. We got n plus 3 here. We've already taken out greatest common factors before. Here we've got a 3. That's the only thing you can do to factor these guys. Okay, boom, common factors right there. N over 3 is our answer, and that's A. When you look at it, that's A. Boom, right there. There's your n over 3. Okay, just simplify it right out. That's what's left. All right, problem 2. Really, these are fractions. Okay, and when we divide fractions, the rule is to change division to multiplication and flip this and multiply. Okay, take the reciprocal. Change this to multiplication and take the reciprocal, which means we're going to flip these two. Okay, so let's take a look at what that would look like. So I've got my n over n plus 3. I'm going to change my division to multiplication, and I'm going to take the reciprocal. I'm going to flip the fraction that follows it. Okay, now when we multiply straight across, but we can cancel. We can cancel something on the bottom with something on the top when it's all multiplication. So we got 1 and 1, so we're left with n over n minus 2. Okay, and that's answer B. Okay, n over n minus 2. Boom, right there, B. Okay, pretty straightforward as far as these problems go. Problem 3. A point is selected at random from a figure. The probability that the point is in a shaded part of the figure is the ratio area of the shaded part over area of the whole figure. Find the probability that the point will be in the shaded part of the figure. So we're going to find the area of the shaded, which is a triangle, that's 1/2 base times height, over the area of the whole figure, which is a rectangle, that's length times width. Okay, so let's take a look over here. Come down here. Get rid of all this. Come back. Area of the triangle we said was 1/2 base times height. So for us here, it's going to be 1/2 times the 6 times the 3x. Half of 6 is 3. 3 times 3, that's 9x. Okay. Now the area of the rectangle is length times width. So I look here, we've got a length of x plus 2x. I'm going to write that as 2x plus 6. And then it shows a width of 6. So we're going to distribute the 6 to both of these. I get 12x plus 36. So there are my two areas. So let's take a look at the probability. The probability that we end up in the shaded area is the area of the shaded area over the entire area of the rectangle, which is 12x plus 36. Okay, I'm going to take out greatest common factor out of the bottom, which is a 12. I get x plus 3. 3 goes into both of these. 3 goes into 9 3 times. 3 goes into 12 4 times. So I've got 3x on the top and 4x plus 9 on the bottom when I multiply it out. I'm sorry, 4 times 3, that should be a 12 right there. Sorry about that. Boom. 4 times 3 is 12. Okay. We look back at our answers, and that's answer D. Okay. 3x over the 4x plus 12, answer D. Okay. So area here over the area of the whole thing, just filled in what they had there, factored what we could, and then simplified just like we've been doing the last couple of sections here. Okay, problem 4 follows the same thing. Find the probability that a point will hit the shaded area. So we're going to take the area of the shaded over the area of the whole thing. Only now we're dealing with circles. Okay, so with the circle, we're going to use the formula for the area of a circle, pi r squared. Let's get rid of all this. And I'll come back here and put the blue. So, here we go. Pi r squared is our formula for both of them because they're both circles. So we're going to get pi times the radius of the shaded is 4x. And we're going to square that. That's going to give us pi times 16x squared. Then we're going to get pi. Now, 2x is the little part there plus the 4x. That's going to be 6x for the entire radius. So that's going to give us pi, and that'll be 36x squared. Okay, now look in this. The pi's cancel out. The x squareds cancel out. We're left with 16 over 36. 4 goes into there 4 times. 4 goes into 36 9 times. 4 ninths. Okay. I think we take a look back here. 4/9 or 4/9. Okay. Put that fraction bar in there in one of the boxes. Okay. So we're good to go there. Moving on. 5-4. Solve algebraic proportions. Okay, how do you solve proportions? We cross multiply. Okay, we set up a proportion as 2 equal ratios or 2 equal fractions. So that's what we're going to do here. We'll set that up for each of these and then solve it. Cross multiply. If Florida wildlife employees caught, tagged, and released 105 alligators on a wildlife refuge, then a year later took a sample of 42 alligators and found that 10 had been tagged the year before, what is the probable number of alligators on this refuge? Okay. Well, let's take a look here. Go back over here. Let's get rid of what we got. Okay. They went and took 42 alligators and found 10 that were tagged. Well, how many alligators were in there before? I don't know, but they had tagged 105 of them the year before. Okay. So, number of alligators pulled, number tagged. How many were out there? Number tagged a year ago. Cross multiply to solve. 42 times 105, 4,410 equals 10x. Divide out your 10, and we get there were 441 alligators is what we would guess to be out there based on this probability of 42 and 10. Okay, 441 alligators. 441 or 441. Okay, just don't write it in the middle. Problem 2, the ratio of girls to boys in the school is 5-4. The school has 268 boys. How many students are enrolled at the school? Well, using the ratio of girls to boys, so many girls to 268 boys, and we got to add the boys and girls to find how many students. Okay, so I'll come back right over here. So we've got 5 girls for every 4 boys. That's G over B. We don't know how many girls there are when there's 268 boys. But there's our proportion right there. Girls to boys, girls to boys. So we're going to cross multiply. 5 times the 268 is 1340. Equals 4G. Divide out the 4. There's 335 girls. Okay. Add the 268 guys that we knew that we already had. Add them up. 3, 1 to carry 0. 1 to carry. There's 603 total students in the school. And 603D. Boom, there you go. Okay. Last problem. They set up the proportion for us. Let's just cross multiply and solve for x. Just remember, when you multiply the 5, it's not 5 times x, it's 5 times x plus 1, so we got to distribute there. And when we multiply here, we're going to have to FOIL. Okay? So, let's get rid of this here. So we start off, we got 5 over x plus 1. And that's equal to x plus 2 over x plus 1. Now some of you may notice, and I'm just going to point this out here, but I'll solve it with cross multiplication. The denominators are the same. If these two fractions are equal and the denominators are the same, then 5 has to equal x plus 2. I'll just do that over here. Subtract the 2 over. We'd better get 3 for x. Okay? That's what should happen, because if this is equal, they have to be equal. Now that's just something because the denominators are equal. That's a little shortcut. But let me solve this the way we've been doing it, and we should get the same answer. So when I cross multiply the 5 by the x plus 1, I should get 5x plus 5. I'm going to FOIL here. Okay? I'm going to FOIL the x plus 1 times the x plus 2. You're used to seeing it like that. I'm going to get x squared. That's plus 2x plus another x. That's plus 3x plus 2. Okay? I'm going to subtract my 5x over. I'm going to subtract my 5 over. And remember, I got to keep them with like terms. I got to get this set equal to 0. Just like we solved earlier. Got a quadratic here. We've got an x squared. I'm going to see if I can factor this so I don't have to do the quadratic formula. Split up my x's. I got a minus here, so I'm going to get a plus minus. What times what is 3? But when I subtract, I get 2. 3 times 1. And 3 minus 1. But I want a negative here, so it's 1 minus 3. 1 minus the 3. So either x plus 1 is equal to 0. That means x is negative 1. Or x minus 3 is equal to 0. Add that over, x is positive 3. Okay? When you look back and you plug these back in, can you put negative 1 back in for x? The answer here is no, because I end up with 0. Negative 1 plus 1 gives me 0, and I can't have 0 in the denominator. So this is what we've called an extraneous solution. We did it correctly, but it doesn't fit back into our problem because we get things like 0 equals in the denominator. So there's our x equals 3 that works. Boom, it's the same thing we got over here. Okay? When you look back over here, there's your answer A. Notice here they put 3 negative 1, but you can't use negative 1. Okay, you got to be careful there because we can't have 0 in the denominator. All right, hopefully this is helping you. I'll be back again to finish up here. We're almost to the end of these. Make good use of this stuff.